Alright, part 1 and 2 gave you the foundation. LLM predicts the next word. Language is pattern, not rules. But there is something we have been dancing around, something that makes people uncomfortable when they really think about it. Why doesn't AI ever say this is 100% true? Why is everything sort of hedged, probabilistic, uncertain? Here's what I want you to understand by end of this video. That uncertainty isn't a weakness. It's actually the entire point. This is the spinal cord of everything that follows. If probability clicks today, and I mean really clicks, LLM will stop feeling magical forever. They will just make sense. So let's go. So in part 1, we learn about how an LLM is a next token prediction machine. It guesses what word comes next. And part 2, we learn that language works through statistical pattern, not grammar rules. Your brain does probability filtering every time you speak. Today we are going one layer deeper. Okay, we are asking what is probability really? Not the casino version, the real version, the version that makes AI works. And more importantly, why is thinking in chances better than thinking in facts? This is a very important question. Okay, here's the problem. When most people hear about probability, their brain goes straight to casino, dice, poker, slot machines. And that's fine. Those are examples of probability, but they are terrible for understanding what probability actually is. Because when you think gambling, you think randomness, you think luck, you think chaos. And that's not what probability means. Here's the real definition of probability. Probability is a way to describe uncertainty when you don't know everything. Please read that again. It's about knowledge, not randomness. If you knew everything, every particle in the universe, every cause and effect, probability will disappear. There would be no uncertainty left to describe. But we don't know everything. We never will. So we need a language for how confident am I? That's probability. Okay, now I'm going to give you a statement, right? I want you to think what you feel when you hear this particular statement, right? Tomorrow the sun will rise. I want you to notice what happens in your brain. Tomorrow the sun will rise. Are you certain? Think about it. Really think about it. Is there any scenario, any at all, where the sun doesn't rise tomorrow? I mean, technically, yes. The sun could explode. A black hole could swallow the solar system. Some physics we don't understand could break. The probability isn't 100%, but it's close to 99.999%. Right? Now try this one. Tomorrow it will rain. What's the probability of that? You can't answer that. Not without more information. Where? What season? What do the cloud look like? What's the weather history? The probability depends on what you know. Different knowledge, different probability. This is very crucial. Probability is knowledge based, not truth based. Right? Read that again. You'll understand that again, right? Probability is knowledge based, not truth based. It's not asking what actually going to happen. It's asking, given what I know, how confident should I be? AI works exactly the same way. Okay, I want to give you a mental model that makes this click. Don't think of probability as a randomness. Think of it as confidence level. Okay, when you say 2 plus 2 equal to 4, my confidence is extremely high, basically 100%. But let's suppose someone says it will rain tomorrow in Seattle in November. Confidence could be medium level, maybe 70%. Maybe Seattle have, gets rain in November. There are aliens living under my bed. My confidence is extremely low, like 0.001%. See, it's not about coin flip. It's not about how sure you are given what you know. Here's what LLM do. For every single possible next word, and there are tens and thousands of them, the model assign confidence level. The might have 15% confidence, A might have 8% confidence, running might have 0.001% confidence, and then pick from the distribution. Not randomly, weighted by confidence. High confident words get picked more often. That's the whole game. Okay, now we get to the real magic. Everything I've said so far is regular probability. But LLM use something more powerful. The magic phrase is, given what I know so far. That's conditional probability. Probability that updates based on context. Let me show you. I like my coffee with. What comes next? Right? What should come? What should be here? Sugar, milk, cream, maybe honey, if you are fancy. Those all have high probability. Makes sense, right? Now, what about I like coffee with machine learning models? The probability of machine learning after coffee with is essentially zero. It's nonsense. The pattern doesn't exist. Here's what's happening. Every word you add changes the probability landscape. At the start of a sentence, millions of continuations are possible. But each word narrows the space, filters the options, makes some things likely and others impossible. LLM recalculate probability after every single token. Not once at the start, after every word. The landscape shifts constantly. That's conditional probability. And it's why these models are so powerful. Let me give you a picture for this. Okay, imagine a funnel. Wide at the top, narrow at the bottom. Okay. At the very top, before any word are spoken, there are millions of possible sentences, literally infinite possibilities. Now someone says the, right? Suddenly the funnel shrinks. Some continuations becomes more likely, others disappear. The quick, the elephant, the purple, right? There are a lot of possibilities, right? Let's say we choose quick. After that, brown. That again narrows it down. Now the quick brown, what comes next? Right? There are few possibilities that are available, and out of those, maybe fox get, we choose fox. Now we are almost at the bottom of the funnel. The continuation space is tiny. So the quick brown fox jumps. Extremely high probability. You have seen this pattern thousands of times. LLM lives inside this funnel. They are constantly navigating the shrinking space of probable next words. Next token they generate further constraint what can come after. That's why the output feel coherent. It's not random, it's probability filtered through context, word by word. Okay, now let's peek at actual math. Just a little. I promise it won't hurt. Probability is a number between 0 and 1. We all know that. 0 means impossible, never gonna happen. Once 1 means certain, definitely happening. Everything else is somewhere in between. Now here's something that trips people up. LLM doesn't always pick the highest probability word. Now think about it. If they did, the output would be incredibly boring. The same sentence over and over. The, because the is often the most common word. Instead, they sample. They roll the weighted dice. High probability word get bigger slice of the dice. They are more likely to be picked, but low probability words can still win sometimes. This is where temperature comes in. You probably seen this setting. Low temperature, the dice is heavily weighted towards high probability words. Output is predictable, focused, safe. High temperature, the weight even out a bit. Low probability words get a better chance. Output becomes creative, surprising, sometimes weird. Let's test this out, right? If I do put it to 0 and then I say generate sample, you can see that you can more or less make sense of these words, right? And it sort of fits. But let's say I go to highest and then I do this, right? It doesn't really fit that much. It's like becoming more and more creative in what it will say. The quantum purple fox transcend beyond the philosophical entropy. So that is why the same prompt can give you different answer every time. It's not broken, it's sampling. And it's why AI text can feel creative instead of robotic. Okay, so now I want you to address something that bother people, right? If AI is doing probability, isn't that worse than logic? Isn't logic more rigorous? Fair question, right? Here's the answer. Logic says if A is true and B is true, then C is definitely true. Probability says given A and B, C is likely. Logic sounds better, right? More certain, more reliable. But here's the problem. Logic only works when you have complete information. When all your premises are definitely true. When does that happen in real life? Almost never. In the real world, you constantly working with incomplete information, uncertain premises, partial data. And logic breaks when information is incomplete. If it gives you nothing, cannot compute. Probability handles uncertainty gracefully. It says, I don't know everything, but here is my best estimate given what I do know. Humans don't think in pure logic. We think in likelihoods. We estimate, we guess, we update as we learn more. That's why probabilistic AI feels human-like. It's modeling how we actually think, not how we pretend to think. Okay, we need to talk about the elephant in the room. Hallucination. That confident nonsense. AI saying things that sound true but aren't. Now that you understand probability, I can finally explain where this is coming from. So we have to understand, what does an LLM not know? It doesn't know what is actually true, what exists in reality, what happened yesterday, fact about the world. Okay, but then what does it know? It knows what it knows it knows what usually follows in text, patterns, statistical relations between words. Here's the problem. Sometimes high probability patterns are false. Let me give you an example. Um, the first president of United States was the high probability continuation is George Washington, and that's correct. But what about the inventor of who was the inventor of telephone, right? The high probability says Alexander Graham Bell, and that's actually contested. There's whole debate about Elisha and Antonio, right? Or worst, the scientific consensus on some controversial topic. The model will output whatever pattern it's seen most often in the training data. That might not reflect actual scientific consensus. It might reflect what gets written about more. This is what hallucination is: a high confidence pattern with no grounding in reality. The model isn't lying, it's not malicious, it's just doing what it always does, outputting statistically likely text. It has no mechanism for checking truth, no fact checker inside, no reality module. This isn't a bug, it's a natural consequence of probabilistic prediction without grounding. Understanding this doesn't fix the problem, but it explains it explains it, and that matters. Okay, so here is what I want you to think this from this perspective, right? I can leave you with one more mental model that will help you understand why LLM works in this way. Think of LLM like a weather forecaster, right? A weather model or a weather forecaster, they predict the rain probability. Sometimes it is wrong, by the way, right? It improves with more data. Doesn't control the weather. It doesn't control the weather. It estimates. Nothing is guaranteed. Now we come to the language model. The same thing. Predict the word probability. Sometimes can be wrong. It improves with more data. Doesn't know the truth. Estimates, but not guarantees. Neither one lies. Both estimate. And here is the thing. You don't get angry at the weather forecast for being wrong about rain. You understand that it's working with incomplete information, making the best prediction it can. Same energy should apply to LLMs. They are not oracles, they are not truth machines. They are probability estimators doing the best they can with the patterns they have learned. Set your expectations accordingly. Alright, time to check if this landed. If someone asks you right now, what is probability in AI? Could you explain it? Think about it. Take 10 seconds. Okay, here's what you should answer. Probability in AI is not randomness. It is a measure of confidence based on past pattern and current context. Very important, current context. Not randomness, confidence. Based on past patterns, what it has seen before, and current context, what it's working with right now. If a sentence makes sense, if you can explain why AI think in chances, you've got it. If that sentence makes sense, actually, sorry, you understand something most people don't. Because here's the beautiful thing. Once you internalize probability, once you really feel that confidence level are the foundations, everything about AI becomes predictable. The impressive stuff makes sense. The failure makes sense. The hallucination makes sense. You stop being mystified. You start being calibrated. That's when you actually use this tool well. That's part 3, the spinal cord probability. If this clicked, you now have the foundation for everything else. Next time we go inside the machine, how does neural network actually learn these probabilities? What happens during training? That's where we get technical, but I'll make it human, promise. Subscribe if you want the next one. Drop a comment with your explanation of probability. I want to hear it in your own words. And seriously, if this helped you understand AI better, share it. Most people are walking around completely confused about this stuff. You don't have to be. Alright, go think in probabilities.